All right, everyone, pay attention. I'm going to give some theoretical foundations to the lecture we're going to have later today on object-oriented programming in Kotlin. This is somewhat advanced and impinges on the kinds of things you're going to learn if you get hired into an IT architecture job at a company and they teach you the real professional ways we do things. Sometimes at school we simplify it down a little bit for the sake of just making it easy for everyone. And this might be a tinge advanced for some people to think about. It is not part of your course outline. You're not going to be tested on it. However, I know there's always some students who really want to get more deeply into the theoretical underpinnings, which I will address now. And sometimes the way we teach object-oriented programming in school is might seem a little bit stilted and awkward because the instructors are trying to convey the concepts without going down to the metal, as we used to say, right? If you do assembly language programming, you recognize that reference, putting opcodes on the CPU registers. So let's go down to the metal. Now I'm going to kick out this lecture note, and the core concepts, you just read it over, right? If it makes sense to you and you like it, then work with it. If not, then we can still get through our Kotlin code tonight without going to too much software architecture. But essentially, there is certain things going on here which I don't think are addressed enough. And I'm going to invite you to go and watch some of my other material, right? So go and watch this video. This pulls back the covers, right? Unveils how things are really done at work. And watch this video, which supports the first video, which talks about how we do lexical analysis. Not going to get into it right now. Go and watch the videos, and you can watch my PowerPoint right here as well. So, preview of our 3 key learning concepts. Often we start teaching students about object-oriented analysis and design, software engineering, after we've required them to start writing object-oriented code. So in other words, the standard practice is we require you to write object-oriented applications, but we don't really teach you how to do that properly. So with your permission, I'm going to give you some X-Man superpowers now to rapidly get your skilling levels up as software developers to the level we are expected to deliver at work. Let's start with some conceptual understanding skills. We write software to run business operations and to optimize the operation of the business. And sometimes I give that question on a test, right? I'm not going to for you, but sometimes I do. And you'd be surprised how many students are studying programming and they have never one time asked themselves the question, well, why do we write programs? What's the purpose of it? And that's quite an important question because everything else flows out of that. The next thing we need to understand is that businesses have a concept called the business domain. The business domain is the bag or the box or the container of all of the data and operations that run the business. So in terms of writing software systems to realize the business domain, we now understand that we write objects which represent business domain objects. What's a business domain object? Well, assuming you're a business analyst at Walmart and you're given a requirement to run a process, if the inventory goes below a certain threshold, then create an agent that will connect with your vendors and order more of that product. That is a business process. So a business domain object is a process or data entity that is a constituent of this bag of operations we call the business domain. That is critical, right? Take out a piece of paper, write it down, do whatever it takes for you to process on that. Because later tonight, when we go and write objects in Kotlin, if you don't get it that ultimately those objects are tools for delivering operations in a business domain, then you'll be what we call a post turtle, right? If you ever see a turtle up on a fence post, you know somebody put it there, it didn't get there by itself. And it is possible, especially at the lower levels, to teach students how to copy and paste code and get something that more or less approximates the right answer. But if you want to have the philosophy of understanding, you have to realize that it all flows outward starting from the business domain. That is the thing. We are writing business objects as in object-oriented objects to automate and implement and realize. A Kotlin object and any object anywhere has methods and data attributes, two types of entities, data and methods. These methods and data fields mirror, paint in software a picture of how the pieces of the business domain work and communicate with each other. We can use software engineering methodologies like UML to formally describe how to compose objects to work with each other. I will be gently introducing some very, very simple UML into our course because if you don't have a conceptualization that objects communicate by method calls or shared field composition, then you're going to be a post turtle, and nobody wants to be a post turtle. So how do methods communicate? Method calls, shared field composition, and UML diagrams called class interaction diagrams are the UML diagram which lets us plan out our shared field composition. And sequence diagrams are our UML entity or our UML charting format for planning how objects communicate with method calls. So using UML enables us to not only by ourselves, but also to collaborate and share knowledge with coworkers, catalog all the entities in the business domain, analyze, record, and share our understanding of how those entities work. In fact, if you read the Agile Best Practices Guide, which is the basis of Agile software engineering, it says right on page 2 of the introduction that the purpose of Agile is to create a way for people to visualize and understand and share their understanding of the SUD or system under design. So when we make our UML diagram, we contemplate the operations and data fields that belong to each business object. So think about the analogy, and I know you guys have all taken relational database in SQL. When you're making a relational database, how do you do it? You write down all of the stuff in your business domain. All of the big pieces of stuff become tables, and then you functionally decompose the constituents of each entity into attributes, which become fields in the table. So UML now, having done all of this stuff, the reward, the benefit we get from doing that is we're now empowered to perform appropriate assignment of responsibility. That is, we figure out which data fields and which operations would be best housed into which classes. With UML, we can do this at design time rather than the very bad unprofessional practice, which I see at work sometimes as well. The programmer will not start thinking about this until they're actually deep in the woods of writing code. So you really want to plan your architecture beforehand. Also, even things that might seem quite simple, such as what names do you call classes, data fields, and methods by, are actually very important for documenting and maintaining your system and training new programmers as they come on the team. So this way, one benefit is you also have your names that you're calling things by planned in advance. For more details on that, watch my video, Lexical Analysis. Lexical means word, analysis means study. In unified process software development methodology, which is what I'm gently sort of exposing some of the key surfaces of it now, that tells us we start by gathering user stories from our stakeholders in the system, and we generate out our system from that. And the reason why we do that is because about 25 years ago, there was something called the software crisis, which was a bunch of really badly written software, badly written because it was written without input from the users who'd be using it. So now unified process says start by putting your users in a room and getting them to share their knowledge of the system under design with you. Watch my video for more details on that. right? So we write software to optimize the operation of our business. The way we encode a business domain is by writing objects which represent business domain objects, which become, so they're domain objects in the business domain. They become business objects in the realization programming domain. A business domain object is a process or data entity that is a part of the stuff, the data and the operations we use to run the business. A Kotlin object or any object has data attributes and methods which communicate by method calls and shared field composition, and we use UML to visualize, plan, and design that before we get to work. Some design heuristics we use to help us think about how, where, and how to park methods and data fields into the best classes or business objects is by applying these principles of high cohesion and low coupling. Not going to talk about it now. Go and read my lecture note here for more inputs on that. Once again, you don't have to do any of this stuff for this course. This is way beyond the course outline. However, if you want to pass the larger and more important final exam called the job interview, they're not going to hire you because you graduated from a college program and you wrote a few assignments. They will hire you if you can talk knowledgeably about this. I know, because I've had students who've done it. So do it if that's what you want. So high cohesion, low coupling, go and read about them. So this is just a restatement because I'm actually writing a book on this stuff and you're getting a beta version draft of my book. And it's going to be rough. Some of it will not be totally assembled together seamlessly, but I think you deserve to have this knowledge. You're entitled to know this stuff. So I don't want to wait till everything's exactly perfect, which nothing's exactly perfect before I kick this out to you. So anyway, our class tonight is going to start here. This is the course outline. This is what I'm going to start talking about. But I will make certain allusions to some of these concepts. When we're making examples, we'll talk about the business domain we're modeling. We'll gently introduce a little bit of UML because you're going to have some mental picture of the objects you're programming anyway, so why not do it properly and use UML? I hope this has been of some benefit to you, and we'll see you in class later tonight.